This is how to draw the dustpan for STEM engineering. First, we'll create a document, name it correctly, and put a sketch on the right plane, and then turn the other sketches off, as seen here. Then we'll create the profile the dustpan will follow using the sheet metal tool. Draw a horizontal line, 8 inches long. And then a vertical line 2 inches long. This next operation may be easier to see in isometric view. Then we're going to use the sheet metal model tool after you exit your sketch. Click sheet metal model and click your lines. We're going to choose extrude, and you're going to select your lines. We're going to choose symmetric. Our depth is 7 5/8. Here's blind, symmetric. Thickness is 1/24 of an inch, or 24 gauge steel. That can also be our bend radius. You can flip it so it's pointing up and say okay. We now have the start of our sheet metal pan. Now we'll create the flanges on the sides from the bottom. Using our sheet metal flange tool, we're going to click on the outer edges. We're going to change our alignment to outer. Change our end type to up to entity with offset. Our entity is going to be the back edge. Our offset will be 5/16. Above the object, bend angle 90 degrees, automatic miter, and use model bend radius. We've now added sides to our dustpan that will bend and cut later. Now we'll create the back tabs and the inside hem. You're going to do another flange, and this time we're going to select the edge of the back part of our dustpan. It really doesn't matter if you select the inside edge, outside edge, or face, because the computer computes all of them. If you get a collision in sheet metal model, you can just click the X to turn it off for now. I want an inner alignment. If you look closely when you change the alignments, you can see what it does and how they try to line them up. Inner is the only one that works because it puts this surface on the inside of our tab. We're We're going to change our distance to 0.375. Our bend angle to 90. We're going to turn off automatic miter, which you see causes it to leave little 45-degree corners on our tabs. And we're going to change our model bend radius to something a little bit larger than our thickness of material, because we have to make it around this corner without it colliding. So we're going to use 0.45. And so now we see we've added our tabs. Now we can create a hem on this inside back edge. A flange is a corner bent at usually 90 to 135 degrees. A hem is a corner bent all the way over to create a seam that is not a sharp edge. So we'll click our hem tool. We're going to click this back edge. We'll choose straight. You can see if you click the button to flip inside or outside how it changes the hem style. Flattened. Flattened means it's very narrow. There's other styles you can look at to play with in the menu, just kind of see what visual look they give. In class, we'll make it flattened. So we want it straight, flattened, a total length of 5/16. Hem alignment. You can check what different options allow. Outer or in place. Leave it at outer so it stays at that top level. And corner type is closed. Again, you should be able to turn off collision in sheet metal model and be able to see what the hem looks like before committing. So now we have an inside hem here and our flanges. Now we're going to create material that will allow for a hem in real life on the outside of our dustpan. Because this hem has a more complicated angle on the front face, Onshape can't actually make the hem, but we can have the material designed correctly so that when we make it in real life, we'll hem it on the hemming machine in class. So we'll create a sketch on the outside surface of our dustpan and view it properly. I'm going to close my menu so I can see a little bit more. I'm then going to project the inside bottom edge, this surface here, so I can see it on my sketch window. So project the bottom corner, or try bottom edge of sketch so that you get a small black dot and line there on the bottom. And I also want to project the top of my hem line. So now I have a dot up here that represents the top of the hem. And a dot over here that represents the face of the inside of the sheet metal of the dustpan. Now I'm going to connect those points with a construction line. Line, turn it to construction. And I don't actually want to touch that point. I want to come to the edge of my work surface lined up with that point, since I'm only drawing on the actual sheet metal itself. Now I'm going to offset that line up 5/16 and then turn it back to a regular line. Remember to use offset. You click the button, click the line, click the direction, and then you can drag and type in your distance. Since I offset the line, I know that the two lines are parallel, so I can draw a connecting line between my offset line and my construction line that will be perpendicular to both lines. Now I'm also going to do something similar towards the bottom front left edge of my construction line, but I don't know exactly how long the line is yet, so I'm just going to draw a line in. I'm going to make it a construction line, and I'm going to use my perpendicular constraint so that now it is perpendicular to my construction line. Then I want to make the line length 5/16, which is the size of my hem, plus a 32nd. Now I actually want to make this endpoint of the line connect to my original sheet metal projected edge. So I should be able to click and drag the line until I'm able to snap it to that point. Now I'm basically going to draw the line going up as well into my offset line. And then from that intersection, I can draw a line down to the front of the nose of my dustpan. Let me set the original line back construction there. Now I'm going to use a line tool to close off this shape with something of a triangle shape. Connecting that front corner dot I already made. Oh, make sure you turn off your construction feature. If you'd like, you could trim this edge here. I'm just going to draw around it. And I want to connect it to the endpoint of the original construction line we made. And it changed from white to gray, so I know that it's a closed shape. Now I want to use that area to extrude remove. Extrude, select that whole area. If you need to, you can uncheck the options and then click inside the exact shapes you want. But if you notice, we want to remove the front portion section of my dustpan down to that inside corner edge, the part above that 5/16 offset line, and then the back corner of the top of that original flange we made. And I'm going to remove through all, so I remove all the material behind my dustpan on both sides of it. And ignore the collision and sheet metal model. So when you're all done, you've removed that piece, allowing for this material to be hemmed on the hemming bender in real life, but Onshape can't actually hem this in your drawing. On to the next step. I now have the basics of the thin sheet metal part of my dustpan. Now we're going to work on the handle. We'll create another sketch on the original right plane, and we'll draw something similar to what we did before when we drew the L shape for our dustpan. So I scooted my dustpan over a little bit to the left so I had room to draw. Now I'm going to draw a vertical line from the top of this bend to the top of the hem. I'm going to need to project those points so I can attach or line up the line with those points. So use your project tool, steal that point, zoom in, steal the bottom point. Now I'll draw lines from that bottom end of the bend straight up that aligns with the top of the hem. If you don't get that perfect, it's not a real big deal. We just want it to be as accurate as possible. Now we're going to draw a horizontal line that's 4 inches long. Now we're going to draw an arc using the 3-point arc tool from the end of my 4-inch line to the bottom of my dustpan, or lined up with the origin if you started on your origin. And the center of the arc is going to line up with both the top and bottom. So if you have struggle with that, you can over or under exaggerate and use the vertical alignment tool to snap the center point of the arc to the end point of the 4-inch line. If it flips it around the other way, try again, this time making the arc radius larger than the line and snapping the vertical constraint. So now we have a line that goes on the outside edge of my dustpan, 4 inches across the top, and then has a basically a 2-inch radius curve here on the right side. We're going to use this outline to create a new sheet metal model. So we'll exit our sketch, sheet metal model tool. I got my menu here so I can see it better. And then when I click parts and surfaces to extrude, or edges or cylinders to, oh, I'm sorry, I forgot. We want to click extrude, just like we did before, that original line on the left, the top, and the curve. You can zoom in a little bit to see that it's starting to create the feature. We want to change to symmetric. Our depth is going to be 3/4 of an inch. Symmetric. Our thickness this time is going to be 1/8, because we'll be using a different material to make the handle versus what we used to make the sheet metal dustpan. The bend radius can be left at 0.042 if it works, or you can adjust it to 1/16 or 1/8. It really doesn't matter. What that changes is the little curve on the inside of our bend when we bend our handle. We want to leave the material going down and click OK. We now see, if I rotate, I have the start of my handle. Now we're going to add the bolt holes for the handle through the dustpan. To do that, we want to create a sketch on the inside back surface of our dustpan. Right click on it, new sketch. Ignore the hem. From there, I want to make two vertical points that either line up with the center of my handle, or since I had my drawing start on the origin, they can be vertically above the origin. If you needed to line them up with the handle because you didn't start on the origin, you could project the top surface of this handle to the front screen and then line them up with that object. I want to dimension it and make it 1/2 an inch from the top of our dustpan hem and 1 inch apart. In real life, we'll drill these holes first so they won't intersect the dustpan. We can see that the distance from the center hole where the hem starts is 0.1875, which will be less or greater than the diameter of the circle we're drilling in that hole, so it really won't have any effect on our project. I'll delete that point so I don't need it shows up. So now we're going to use the hole tool after we exit our sketch. You could have drawn circles on those spots and extrude, cut, remove. One circle I want to be the same all the way through, and one circle I don't, because we're going to learn a different technique in class using our tools. There's the hole tool. It's hard to find when I have my menu compressed for the screen movie. So the first hole I make is going to be on the top point. And it's going to be a simple hole. It's blind, ANSI, size, drilled, and our drill size is 0.25 or 1/4. If the computer doesn't automatically select merge scope and choose both parts, you may need to click merge scope and click both the dustpan and handle. Make sure you set your depth to only about 0.5 or less than an inch, otherwise it'll extrude too far and actually go through the back area of the handle, and we don't want that. There's our first hole. That'll be for a regular bolt that we put through the dustpan. We're going to repeat the process for the bottom point. You might need to turn the sketch back on to get to it, but this time we're going to make the hole a little different. So this time, I'm going to click on the hole and first enter my parameters of 0.25 and 0.5. Then I'm going to change it from simple to counterbore. A counterbore hole is one that starts out big, goes to a certain depth, and then changes to small. Our original parameters didn't change of the hole diameter and the hole depth. Our inside parameters, though, should be set so that the counterbore diameter is 0.25, our counterbore depth is our sheet metal thickness, 1/24, and we're going to change this from drilled to tapped. and if it needs to, reset the size back to 1/4. Sorry, it keeps resetting my size. In the end, you want a hole diameter that's 0.201 approximately, or about 7/32 in diameter. A counterbore diameter of 0.25. A depth on that counterbore of 1/24, which is our sheet metal thickness. And then a regular hole depth of about 0.5. You can see what it's doing is it's making a larger hole in the dustpan and a smaller hole in the handle material. This will be done in 2 separate operations in the lab in real life. But what this gives us is the tapped hole size that we're going to actually drill in our handle to learn how to tap metal. Double check your merge scope and see that the hole works. Now I'm going to create the hole in the handle for hanging and then assemble the dustpan. So I'm first going to create a sketch on the top of my handle. And draw a circle that is 3/8 in diameter. And I want to make it 3/8 away from the edge of our big bend. And I want to make sure it lines up vertically with the middle of the bend. So if you haven't applied a vertical constraint yet between the center of the bend line and the circle, you can go ahead and do that. Now I'll just extrude remove that area. At a depth less than 2 so I don't go through any more material. I could have also done this by just putting a point on that spot and then using the hole tool again. Now I'm going to go from my part studio to my assembly one so I can put the parts together. I'm going to insert the features. I can just click part studio 1 and then drag them apart. Now I can use the fasten mate to fasten either holes together. So I'm going to choose the front surface of the top hole on my handle so that the blue line is facing perpendicular to the center, or aligned with the center of the circle. And then I'm going to pick that same spot on the back circle of the dustpan. I could turn around and click the same thing, or I can just zoom in and click the back edge of that hole that the 2 surfaces touch. Since I'm using a fastened mate, I only need to do it once, and I shouldn't need to flip the primary axis or change my reorient for secondary axis, but depending on what parts you clicked, it might be necessary. After that's done, I've locked the handle in place with my dustpan. And now I'm going to add in standard content similar to what we'll use in the lab. To do that, we're going to say insert again, standard content. This time we're going to choose ANSI, inch, bolts and screws, hex bolts, and then 1/4x20 and 0.5. It may be hard to see, there's a button down here that says insert and drag to snap. What that allows me to do is click insert, and then I can find a round feature that I can snap the handle to for the bolt, and it automatically inserts the bolt. Ignore the fact that the bolt collides with the hem. In real life, the bolt will just sit on top of that hem. We're going to do the same thing again, except this time we're going to change the length of our screw to 0.375 and say insert again, and insert this one in the bottom hole. And click OK. If you accidentally select the wrong surface and the bolt is too far in the material, you can change that by going to the mate features of that object and changing the fastened offset. So for example, if it was inside the material, it looked something like this, you would probably need to offset it, the Z out, the thickness of our material, which is 1/24. I'm going to turn that off since I selected the right surface. One way to see is if I adjust the screen so I can kind of see the two parts touching in another view. So now if I look on the back side of my handle, I see the short one that is going through the handle hole that was tapped. When we tap a hole, it means that it's threaded, so it acts like a nut, and so I don't need to put a nut on it. But that process takes a little bit longer in the lab, and it's a little bit more difficult to do, so we're only going to do it once. On the other hole, we're just going to drill a 0.25 diameter hole, put in a 1/4 inch bolt, and then insert a nut on it, which will use a standard 1/4 inch nut. So now we can say insert standard content, ANSI inch. Instead of bolts and screws, we want nuts. Machine screw nuts, hex, 1/4 by 20, insert, and try and select the surface of the back of the handle where the bolt sticks through the hole. Again, if you need to change the offset, you can. It's really not that big a deal, but you needed practice with using standard content that's already available online. That's why we did this operation. So now I click OK. Now my dustpan is done. If you don't want to see the handles that show up for the screws, you can go into the standard content and turn off that near feature that shows up, showing where the handles automatically are. Now your dustpan is done this part of the assignment, and you can screenshot the various components and put them in your notebook. The last step of the assignment is to create a drawing. Insert feature, create drawing. We again want to use the ANSI inch template, no views, and click OK. Now when the insert menu pops up, we're going to change it from standard 3-view parts to flat pattern. Because we used the sheet metal tool, it allows us to use the flat pattern tool in the drawing menu to get what the part would look like if we were to unbend it after we did the model. That's the big benefit of using the sheet metal pattern tool inside Onshape or other CAD softwares that are similar. So I'll do the flat pattern of the dustpan first. I'll change my view to probably the top. Scale 1:2. Set our view simplification to automatic. I'm going to try to leave a little space on both the left and right side and top and bottom. I'm going to place it in my window for the purpose of doing dimensioning. After I've placed the one view, I can hit escape. And I'll repeat the same feature. Insert view. If you need to click insert again, you hit the handle. Again, we want a flat pattern of the handle. escape. Now we have both pieces. What this allows us to do is a machinist would normally print these to scale and allow them to help lay out his parts on a piece of material. You students won't need to do that because I will pre-cut a template that you will use to trace to save us the step of having to print these parts. But after we dimension it so we know that where parts go, we'll then put the copy of this in our notebook like we did before. So now I want to dimension the overall features so I know how much approximate material to use, and then I can save it and put it in my notebook. So I'll do things like dimension how wide it is. If you don't get the exact same numbers I got, that's not a big deal. I will not be using these exact numbers in real life with the pattern in class because I've simplified the pattern a tiny bit to make it easier to do on our machines. And Onshape is also set to round a little bit, so don't worry about the rounding error. But as you get better with doing this type of stuff in the lab and in real life, you can use these tools to determine how big of a piece of material you need to make something if using sheet metal. I'll dimension the handle as well. One important feature I forgot is to lay out where the holes go, because we will actually use that information in real life. Another benefit of why it was really important to put the holes in the model. This will allow us to lay out the flat pattern and cut the material, then drill the holes in real life before we start doing all the folding. If your text gets in the way, you can click on the little points and drag it out of the way a little bit. Make sure to mention the diameters of the holes, especially on the handle, so that we remember which size to drill them when we drill them in the lab. I try to move some of the text out of the way so I don't have crossing text endpoints. So we have the length and the width of the handle and where the hole locations are. Just remember to put the last bend in. You may or may not get a hidden line that shows up for this larger curve bend, but it's there as a separate piece. So now we have the length and width and hole features of the handle, approximate length and width and hole features of the dustpan. Now you can fill out all the important detail down here, like the scale, your name, date, title, and then to turn in the assignment, you're going to turn in both the notebook link of the assignment after you put everything in it, and I want you to turn in the PDF of the views so that you know how to export a PDF. To do so, you're going to right click on drawing 1, export, change your format from DXF to PDF. You can download it. It'll pop up here in the corner in about 5 seconds. Save that to a location like where your notebook is stored, and then you can upload this PDF file. Please rename it before you upload it so that it's named your name dustpan. That's all you need to know for doing the dustpan. Once you're done this and you've turned in the assignment in Schoology, I'll be able to look at it and I will get you started on actually making the dustpan in class. Thank you for watching.